A United States Navy destroyer just eliminated 4 enemy drones at sea without firing a single shot. No missiles, no gunfire, no explosions echoing across the ocean. Just a silent beam of light. And seconds later, the drones dropped from the sky. The weapon costs almost nothing to fire, never runs out of traditional ammunition, and attacks at the speed of light itself. What sounds like science fiction is already a battlefield reality. Right now, this technology is operating aboard U.S. warships, and military powers around the world are watching with growing concern. Introduction. For decades, the United States Navy has been fighting a quiet battle, not against a rival nation, but against a problem no missile, cannon, or warship design has ever completely solved. How do you defend a multi-billion-dollar warship from a drone that costs only a few $100s? That question became impossible to ignore in the Red Sea. Beginning in 2023, U.S. Navy destroyers were launching million-dollar interceptor missiles night after night to destroy cheap Houthi drones. Week after week, the pattern continued. The cost imbalance was staggering. Missile inventories were shrinking, while waves of low-cost drones kept coming. The Navy needed a new solution, and the answer didn't come from a larger gun or a faster missile. It came from a concentrated beam of light powerful enough to burn through steel. This is the story of the U.S. Navy's laser weapon program. What it is, how it works, why it matters, and why many defense experts consider it one of the most significant breakthroughs in naval warfare in the past 50 years. If you support the strength, innovation, and technology of the U.S. military, drop a comment below and stand proud. The problem that created the laser. To understand why laser weapons are becoming so important, you first have to understand the problem they were built to solve. Modern naval warfare has changed dramatically. When most people think about threats to a Navy warship, they imagine enemy ships or fighter jets. But today, one of the biggest dangers isn't a warship or an aircraft. It's the drone. Small, inexpensive, and often deployed in large swarms. During Red Sea operations between 2023 and 2025, United States Navy ships launched hundreds of air defense missiles to protect both military and commercial vessels from Houthi drone and missile attacks. The missiles were effective, but extremely expensive. Each interceptor can cost anywhere from $1 million to $4 million, and every ship carries only a limited number. Once those missiles are used up, the ship must return to port to reload, a process that can take days, and during that time, its ability to defend nearby ships is greatly reduced. Enemy forces quickly recognized this weakness. Their strategy became simple: overwhelm defenses with large numbers of cheap drones until the defending ship runs out of costly missiles. Even the Phalanx close-in weapon system, the final line of defense on many Navy ships, has limitations. Its rapid-fire cannon burns through ammunition so quickly that only a few bursts can nearly empty the system. This became more than just a financial issue. It became a serious strategic problem that modern adversaries are already exploiting. The Navy realized it needed a completely different kind of weapon. One without traditional ammunition, one that wouldn't run out after repeated attacks. The solution was light itself. Meet Helios, the weapon that may change naval warfare forever. Its name almost sounds futuristic. Helios, short for high-energy laser, with integrated optical dazzler and surveillance. Developed by Lockheed Martin under a $150 million Navy contract awarded in 2018, Helios is no longer just an experimental concept. It is now a fully operational weapon installed aboard a real United States Navy warship. That ship is the USS Preble, an Arleigh Burke-class destroyer, recognized as one of the most advanced surface combatants in the world. And Helios isn't sitting on a test platform or hidden inside a laboratory. It is fully integrated into the ship's combat network, directly connected to the Aegis combat system, the same system responsible for tracking threats, assigning weapons, and coordinating the ship's entire air defense operation. That integration is extremely important. Helios is not simply a laser mounted on the deck. When the ship detects a threat, the combat system can automatically assign Helios to engage it, just as it would select a missile or a naval gun. Everything operates through a single combat interface, allowing the crew to respond faster and more efficiently. So how does it work? Helios produces a concentrated beam of directed energy with power exceeding 60 kilowatts. To put that into perspective, that is enough electricity to power roughly 60 homes at the same time. The laser locks onto a target and keeps the beam focused long enough to generate extreme heat. Depending on the target and the engagement mode, the heat can either physically destroy the threat, a hard kill, or disable its electronics and sensors, creating a soft kill that leaves the drone airborne but completely blind and uncontrollable. The system has reportedly demonstrated effective engagement ranges of around 6 miles. And unlike traditional missiles, which require time to travel toward a target, a laser strikes instantly at the speed of light. Target detected. Beam fired, threat neutralized. Then there's the part that could completely change naval warfare economics. The estimated cost to fire Helios is only a few dollars in electricity. Compare that to a standard air defense missile, which can cost around $1 million per launch. In simple terms, the Navy could fire the laser hundreds of thousands of times for the price of a single interceptor missile. Before we continue, take a moment to like the video and subscribe. Most viewers watch without subscribing, but your support makes a huge difference to the channel. The moment it proved itself. For years, the high-energy laser with integrated optical dazzler and surveillance existed mainly as a testing program, impressive in demonstrations and controlled environments. But real warfare is unpredictable. Navy commanders needed proof that the system could perform at sea under operational conditions against actual moving threats. That moment finally arrived in 2025. The USS Preble carried out an at-sea counter-drone exercise during a United States Navy operation. The targets were 4 unmanned aerial vehicles flying over open water. The high-energy laser with integrated optical dazzler and surveillance engaged them. All 4 drones were successfully neutralized. This marked the first confirmed multi-target engagement, using the system against multiple aerial threats in a realistic maritime environment. What made the event even more interesting was how the news became public. The success was not first revealed during a Pentagon press briefing or a Navy media event. Instead, it appeared inside Lockheed Martin's fourth quarter financial report for 2025, where the company disclosed the achievement to investors. That detail matters. It suggests the demonstration was not staged simply for publicity. It was a serious operational milestone important enough to be presented as a major business achievement. In early 2026, Vice Admiral Brendan McLean, the Navy's senior surface warfare officer, publicly confirmed the successful testing. His message was straightforward. The 2025 demonstrations paved the way for future laser weapon systems across the fleet. He also stated clearly that the Navy is committed to advancing laser technology and that the vision of lasers installed on every ship could eventually become reality. That was not marketing language. It was a senior fleet commander describing the Navy's future direction. Then came an even bigger development, a real-world combat deployment, Operation Epic Fury. On February 28, 2026, United States Central Command released imagery from a major strike operation targeting Iranian positions. During the operation, R. Lee Burke-class destroyer warships launched Tomahawk cruise missile strikes in an active combat scenario. But analysts examining the released images noticed something significant aboard one of the destroyers: the Optical Dazzling Interdictor Navy laser system. The Optical Dazzling Interdictor Navy is a lower-power directed energy weapon designed primarily to blind and disrupt drone sensors rather than physically destroy targets like larger laser systems. Even so, its presence during a real combat operation confirmed something many defense observers had long anticipated. Shipborne laser weapons had officially entered frontline naval operations. Several Arleigh Burke-class destroyer ships have already received the Optical Dazzling Interdictor Navy system. The weapon is compact enough to be installed without major structural modifications, while also providing valuable operational data to Navy planners and engineers. The Red Sea operations, Operation Epic Fury, real drones, real missiles, real laser weapons. The transition from experimental technology to battlefield reality is no longer a future possibility. It has already begun. Why did the Navy take so long, and why is this moment different? The United States military has been researching laser weapons since the Reagan administration. That means more than 40 years of development. So why are these systems only becoming operational now? The truth is simple. The technology was not ready. High-energy laser weapons require enormous electrical power. Earlier warship designs simply could not generate enough energy without affecting other critical onboard systems. Beam quality also became weaker over long distances, while heat management created another major obstacle. In many early systems, the laser itself overheated before it could finish an engagement. Then there were the environmental challenges: salt spray, humidity, atmospheric distortion, ocean turbulence. All of these factors affect how a laser beam travels through the air. Systems that performed well in dry desert environments often struggled badly at sea. Daryl Caudle, the current chief of naval operations, spoke very openly about this issue when he previously served as Fleet Forces commander. He publicly admitted that the Navy should be embarrassed by how slowly progress had moved on directed energy weapons. He did not hide the problem. According to him, the technology had been studied for decades without producing systems the fleet could actually depend on in real operations. But now the situation has changed. The growing drone threat in the Red Sea gave the program a new sense of urgency. Rising defense costs also made the economic argument impossible to ignore. At the same time, major advances in industrial laser technology created a reliable technological foundation. The same powerful lasers used today in manufacturing and metal cutting helped engineers develop practical military systems. That is one reason the high-energy laser with integrated optical dazzler and surveillance system succeeded where earlier projects failed. The Navy did not need to invent laser technology from the beginning. Instead, it had to learn how to adapt a powerful industrial tool so it could survive harsh ocean conditions and integrate directly into a warship's combat system. Now that challenge has largely been solved. And the next race has already begun, the race to scale the technology even further. What comes next? The future is already taking shape. If the high-energy laser with integrated optical dazzler and surveillance system at 60 kilowatts can already destroy drones, imagine what happens when the power level increases dramatically. The United States Navy is already working toward that future. A program known as Longbow is developing what could become the world's first 400-kilowatt shipboard laser weapon. That would make it nearly 7 times more powerful than the current high-energy laser with integrated optical dazzler and surveillance system. At that level of power, the mission changes completely. The weapon moves beyond engaging drones and small attack boats. It enters a category where cruise missiles themselves could become viable targets. Anti-ship cruise missiles remain one of the greatest threats, facing a U.S. carrier strike group. China has invested heavily in them. Russia operates them. Iran has already used them in regional conflicts. If a laser weapon can reliably intercept an incoming cruise missile, the entire defensive strategy surrounding carrier operations changes overnight. Daryl Caudle has gone even further in discussing the future. He has publicly spoken about ambitions for megawatt-class laser systems aboard next-generation warships. A megawatt equals 1,000 kilowatts. At those power levels, directed energy weapons could potentially engage ballistic missile threats, something that would represent a major leap in naval defense capability. Then came another major development. In December 2025, Donald Trump announced plans for a new class of heavily armed warships called Trump-class battleships. According to the proposal, these ships would be designed around advanced technologies, including hypersonic weapons, electromagnetic railguns, and high-powered laser systems as primary armaments. Directed energy weapons were described as a central feature of the future battleship design. Looking ahead, Admiral Daryl Caudle and other senior Navy leaders see the Battleship Initiative as the type of flagship program the Navy has needed for years, a project with presidential attention, industrial backing, and long-term defense budget priority. That kind of pressure matters. Decades of research papers and experimental testing struggled to push the technology into large-scale deployment. But a presidential directive combined with a completely new class of warships could accelerate development far faster than before. The shift is already becoming official policy. The Navy's Fighting Instructions Guidance, released in early 2026, now includes a detailed directed energy strategy with defined capability goals, operational timelines, and investment priorities tied directly to future fleet platforms. That is no longer just experimental research. It is a roadmap for deployment. The honest limitations. Good military reporting doesn't focus only on victories. It shows the complete reality. And the full reality of laser weapons includes limitations that the United States Navy is still working to overcome. The biggest limitation is straightforward. A laser weapon can only engage one target at a time. In a coordinated swarm attack involving dozens of drones launched simultaneously, the high-energy laser with integrated optical dazzler and surveillance system operating at 60 kilowatts can focus on one drone, while the others continue moving toward the ship. That is why Navy commanders continue to emphasize that laser systems are not replacements for missiles. Instead, they are designed as an additional defensive layer, a rapid first response option capable of eliminating smaller, low-cost threats before expensive interceptor missiles need to be used. Range is another important factor. The high-energy laser with integrated optical dazzler and surveillance system is most effective at relatively close distances. As targets move farther away or travel at extremely high speeds, the effectiveness of the beam begins to decrease. The system also requires what engineers call dwell time. The laser must remain focused on a single point long enough to generate enough heat to damage or destroy the target. Against fast-moving or maneuvering threats, maintaining that precise focus becomes far more difficult. Weather conditions create additional challenges. Fog, heavy rain, humidity, and dense atmospheric conditions can weaken laser performance and reduce beam effectiveness. Since the Navy operates globally from the Persian Gulf to Arctic waters, any weapon system affected by weather must always be supported by backup defenses. None of these limitations are secret. Navy officials have openly discussed them in public statements. But importantly, these are engineering challenges, not impossible laws of physics. And with every new generation of directed energy systems, those limitations are being reduced. The USS Preble currently serves as a real-world test platform for these technologies. Every deployment, every exercise, and every engagement provides valuable operational data. Those lessons are already shaping the future of every carrier strike group that sails. The Navy is building experience in real time. With every demonstration, every deployment, and every successful engagement at sea. Conclusion. This is where the United States Navy stands today. One destroyer now operates the most powerful shipboard laser weapon ever deployed at sea. Several additional warships already carry the optical dazzling interdictor Navy system during active operational deployments. A 400-kilowatt laser weapon is currently under development, while future battleship programs are expected to introduce megawatt-class directed energy systems. And for the first time in naval history, a laser weapon became part of a real combat task force during an actual strike operation. For decades, the Navy remained trapped in an expensive cycle, using multi-million-dollar missiles to defeat extremely cheap threats. Directed energy weapons begin to change that equation, not because the technology is perfect, but because for the first time, a U.S. warship can defend itself against the most common modern threats at a cost that makes both tactical and economic sense. The men and women serving in the U.S. Navy have always adapted to new eras of warfare. They adapted to naval aviation. They adapted to nuclear-powered fleets. They adapted to the missile age. And now they are adapting to the era of directed energy. Today, the speed of light itself has become a weapon, and it now serves aboard the U.S. Navy fleet. If this video gave you a new perspective on the future of naval warfare, make sure to like and subscribe so you don't miss the next one.